All right. Hello there. I think we should be live now. Fingers crossed. I wonder if I can see. Yep. Hello, everybody. This is James from Lambda Lounge. I've got Alex as well from Scala Manchester with me. Yep. Hello, everyone. This is the sort of joint Lambda Lounge Scala Manchester meetup tonight. Yep, we've got both the logos. It's beautiful stuff. Let's go for the next slide. Yep. So as mentioned last time, we've got the Discord for the Lambda Lounge for the chat afterwards. If you already have Discord, you can scan that QR code that's on the slides, or the link that's on the other side of the slide puts you into a channel where you can accept our rules. So we kind of want a nice community and all those kind of things. So if you want to do that, please do feel free to come along. That link will be on the screen at the end of the talk as well. So don't worry about it if you don't get it this very second, or we'll probably post it in the YouTube stream as well. So as well, thank you very much tonight for Disney Streaming Services for sponsoring. So the library, the kind of motivator of all of this is a library that Disney open sourced, and we're going to have a look at that library as part of the talk. Yeah, we're all good, and thank you again to Disney. And this is the kind of plan for tonight. Do you have anything, Alex, before we?
Yeah, no, just yeah, thank you, James, for doing all of the legwork and all of the organising. That's I've just shown up and sort of said hello to everybody. So I've had quite an easy ride this time. So thanks very much for doing it. Yeah, for everybody who's come via the Scala meetup, thank you very much. You know, we're hopefully we'll have another talk in August, but it may be September, depending on speakers and finding an interesting topic. Finding people to talk is always difficult, but yeah, hopefully we'll get back on top of that and get some regular meetups going again. Yeah, and we'll be more than happy to do some shared ones if we ever you have any more Scala focused ones. We're happy to collaborate. It's been good. Cool.
All right, I think we'll bring Oliver in because I don't really have anything else. Hello. I think we're good. Let me take the slides away.
Hey guys.
I'll get up. All right,
awesome.
Cool. We've got your slides, Oliver.
Perfect. Thank you.
And yeah, go for it. Cool.
Let's get going then. All right, Olivier. I've been a Scala developer for more than 7 years now. I work for Disney streaming services, and I currently live in the south of France. I used to live in Manchester, actually. I know that this meetup would probably happen in the northern quarter of Manchester if it wasn't for the coronavirus situation. But yeah, thanks a lot for organizing this, James. It's absolutely great to be able to speak from my remote area. So I'm here to speak to you guys about a Scala library called Cat's Effect, which is a library that aims at providing pure functional constructs to the Scala language. And I'm also going to talk about a test framework that we've recently open sourced at Disney. It's called Weaver Test, and yeah, I'll get into that later. The agenda for tonight: a little bit of an introduction about the Scala language. Then I'll talk about why pure functional programming matters. Then some introduction to the Cat's Effect library, and finally a sort of little intro to Weaver Test, our library. So Scala as a language. Scala is a strongly typed, statically typed language. It compiles to the JVM primarily, but it also compiles to other platforms, namely JavaScript, and also we've got a native compiler. It's very much concise compared to Java, and it's got a somewhat, let's say, an okay type inference system. The type system itself is really good, but the type inference is a little bit, let's say, a little bit better than, or much better than Java, but not as good as Scala. Scala is an imperative-friendly language. It gives you all the constructs that you would have in imperative programming languages, such as for loops, while loops, conditionals, mutable variables. But it is also very much a functional language, and functions are first-class citizens, which lets you sort of write this kind of very nice declarative logic that is extremely concise and pleasant to read. Scala, as a whole, is a very unopinionated language. And in my personal opinion, it's a strength in the sense that it provides, or it enables to use it in a lot of different contexts, namely front-end programming, back-end programming, big data, dirty little scripts, all sorts of contexts. However, in the past few years, pure functional programming has been gaining traction, and especially in the context that I work in, namely back-end software engineering. And I would like to talk about why pure functional programming matters. And in order to do that, I'm going to use music as a sort of example throughout the talk. Okay, so you can usually play music from a program by using a MIDI interface. MIDI is a very low-level format that lets you sort of translate from integer numbers to frequencies. And so you can refer yourself to a chart like this one to understand which number corresponds to which note. And because Scala is a language that strongly integrates with Java, you can tap into the Java standard library, and in particular the JavaX sound MIDI package, in order to acquire some sort of connection to your or some sort of interface to the MIDI system. So that the interface gives you like very basic constructs to let you play sound from your JVM. And once you've acquired a connection to that interface, you can sort of implement a function like this one, or a method like this one, which lets you play a note. And so in this case, there's three things to sort of understand about this particular function. So the first thing is the fact that we are sort of simulating the pressing of a key on a keyboard. And that's a side effect. So as soon as your runtime interprets this line of code or evaluates this line, it will result into a sound being played on your computer. Then we're blocking a thread for a given duration, and then we're simulating the release of the key. So it's pretty simple, and it lets you simulate a note or a pressing of a key for a given duration. And so using that note method, that note function, you can simulate what is basically a piano by referring yourself to the chart we saw earlier. And by using that piano, you are able to play a little song or a sequence of notes. So initially, I had planned to demo directly from the JVM program, but we realized when we did the trial of the software we're using for streaming that we couldn't actually play sound from the computer directly. However, we figured out that we could play sound from a browser page, and that's what I'm going to do. I actually re-implemented what I had implemented initially for the talk in terms of Scala.js, which is the JavaScript compiler for Scala. And when I'm going to play this, hopefully you guys will hear a sequence of notes. I'm just going to ask, can anybody tell me whether it was successful in the chat or whatever? Yeah, quiet. Let's see if I can. I don't know whether I can set the sound actually on this. Don't know whether that's gonna make a difference. Anyhow, I'll just move on then. So that is great. We're able to simulate a sequence of nodes or play a sequence of nodes. However, what we are not able to do is represent a song as a list of nodes. And that's because as soon as we invoke one of the note function or the nodes that we implemented for a piano, a side effect is going to be performed. So in this example here, where I'm attempting to create a list containing nodes, what's going to happen is that at the creation of the list, the side effects are going to be triggered. And I'm going to end up with a list that contains value of no meaning whatsoever. I can't do anything with that list. If I concatenate the list with itself, it's just a bunch of empty values. Or if I reverse it, it's exactly the same thing. There's also some further shortcomings that arise. For instance, we can't, or it's pretty hard to play two notes at the same time, for instance, because, well, every time we're going to perform a side effect, it's going to be played, and so we can't really refer to it to sort of combine it with itself. So what we're seeing here is that the imperative triggering of side effect hinders expressiveness. It prevents you from expressing a bunch of things that are quite desirable, like expressing a song as a sequence of notes or a playlist as a sequence of songs. So what do I mean when I say side effect? So a side effect is pretty much anything that's going to get information to leave your runtime, or that's going to get your runtime to query information from the outside world. So that involves any sort of log to the standard output that you would do in the running of your program. It involves generating random values, anything that has to do with file system interactions, writing a file, reading from file, network calls, obviously, and playing a sound or displaying something on the screen. And the problem with side effects is that they break a very useful property that's called referential transparency. And referential transparency it essentially means that in a given program, you can take a value and replace it by its definition, and that doesn't change the meaning of the program. So in this case, for instance, we are generating a random UID and assigning it to value. And if we compare the value itself, it's always going to return true. However, if within this comparison we are replacing the value by its definition, then it's always going to return false. And so that's a very simple example of how a side effect breaks referential transparency. And the thing is, referential transparency is the property that enables compositionality. So it's a property that lets you take values together and combine them as if there were Legos, or as if there were integers, for instance, that you can combine very simply using operations like additions and multiplications. So as soon as you lose referential transparency, you're not able to do that anymore. And you have to think about your program in terms of how it's going to impact the outside world. So what we are witnessing here, or what I'm trying to express, is the fact that there is a difference in software between executing something and describing something that is going to be eventually executed. And that is equivalent to the difference between a declarative approach and an imperative approach. The imperative approach being the one that triggers the side effect as soon as it's being interpreted or as soon as it's being declared. Whereas versus the declarative approach, which essentially describes the desire to eventually run a side effect. And that same difference is what differentiates pure functional programming from the rest of the programming paradigms that we have in the software industry. All right. So during the 19th century, Thomas Edison invented the phonograph, and it was the first device that let people record music in one place and listen to it in another. And from that point on, listening to music became decoupled from making the music. So you could sort of listen to music in a different place or time than the place or time where it actually was recorded. And from that point on, it became possible to use music or consume music in a significant or in a large number of other ways or means. And it's my opinion that the invention or the sort of the pure functional programming paradigm is as significant to the software industry as the invention of the record was to the music industry. All right, so in the Scala ecosystem, there are no out-of-the-box construct that lets you refer to side effects transparently. So you don't get that out of the box. However, the language is rich and expressive enough that it lets you come up with your own construct to achieve that same purpose. And in the Scala ecosystem, there's 3 different libraries that aim at providing you with this ability to refer to side effects without actually executing them. And the one that we're going to talk about is specifically Cat's effect. The reason why we prefer, or library authors usually prefer Cat's effect, is that because it provides a bunch of abstractions that let interoperability with the 2 other libraries possible. And therefore, by coding against Cat's effect, you're usually able to cater to all 3 libraries. All right. Okay. So primarily, the sort of construct that Cat's effect is really built around is the IO construct, the IO data type. It's a data type that lets you capture a side effect without actually running it. And so you can assign it to value and run it later on by calling this unsafe run. So don't think I can actually, or people actually see my mouse pointer here. So I'm just going to describe what's going on here. So we are defining a print string sort of method that wraps a side effect into this IO construct. And because the IO construct is lazy, it's actually just going to capture the definition. And then we can assign this IO to a value and run it using a unsafe run. So because the effect has merely been captured and not actually executed, we're able to use a number of composition methods to describe a flow of actions. So for instance, in this case, we are composing the side effect with itself in a sequential manner. manner, meaning that we're going to execute it twice in a row. And it's only at the point of calling an unsafe run that the side effect will be executed once again. But it doesn't really, or it doesn't just let you compose things in a sequential fashion. It also offers you a bunch of other combinators that are extremely useful and extremely concise. So for instance, in this case here, we are expressing the fact that we're going to print both hello and word, the two strings. And we are just delaying the printing of word by 100 milliseconds. So the Katz effect lets you do that. It lets you sort of schedule side effects very, very simply. And so we can still assign this delayed side effect to value and then take two of the IO values that we've built, shove them in a tuple, and run this parttupled method that is going to execute the two in parallel. And so despite the sort of delayed word computation being referred to in the first slot in the tuple, it still gets run afterwards because of that 100 milliseconds delay. And that sort of composability scales beautifully. You can use it with a bunch of different collections. You can use it with tree-like structures, for instance, or any kind of traversable sort of construct. So in this case, we want to print the list of 1 to 5, or each element from 1 to 5. And we are just constructing a list of those things and traversing that list by calling our pure functional function on each element. And once again, like, we haven't sort of triggered anything until the point of calling unsafe run. So the game here, sort of the sort of approach that pure functional programmers try and take in the Scala ecosystem, is to differ as much as possible the point in their program at which they call this unsafe run thing, and to try and really compose the side effects together using those combinators until the very last statement on the main method, where then they will run the program. And by sort of differing this decision, we're able to keep composing the side effects in very simple ways and in a very expressive manner. All right. So one very important thing as well is that you're able to pass a side effect to a function. You're able to construct a bunch of extension methods for it, or process it in a totally generic fashion by just passing it as a parameter to some construct. So here, for instance, we're essentially expressing that we're adding a repeat method on any IO value. And it doesn't really matter what the side effect is going to be, whether it's going to be playing music or pulling some endpoint somewhere in the cloud, or anything of the sorts. It just works generically, and that's really, really empowering. So also, not only you get this sort of ability to reason generically about things, but you also get this very simple API for forking processes, or computations rather. And you can also cancel computations that are currently running. So in this example here, we're expressing the fact that we want to print word delayed by 100 milliseconds, as we did before. but we're also expressing the fact that we are going to do that forever, essentially, by repeating it. And then we're calling start, which is going to just express the fact that we want to run this never-ending print of word in the background, and we are getting a reference from it. It's a fork. It's what I named fork in this example. So we are starting to print word in the background. Oh yeah, by the way, for those who don't do Scala on a day-to-day basis, there's 4 construct here expresses a sequential composition of operations. So each step is going to be executed in sequence, and that works with both lists and also any sort of construct that abide to a certain interface, which is the case for I/O. So back to the example, we are forking the never-ending print of word, and then we decide, oh, we're going to print hello. And after a delay of 500 milliseconds, we're going to cancel the printing of word. And after having canceled it, we'll print a double exclamation mark. And so, let's see, there you go. And so when we execute this, as we would expect, the first thing is the print of hello. And then, because it was delayed, we start to see some words being printed. And we have enough time to print 4 of them because each print of word is delayed by 100 milliseconds. After which that background computation is being canceled, and we finish the computation by running the print of the double exclamation mark. So it's really, really concise. It's really simple. It's beautiful, and very accessible. Okay, so back to our music sheet. Sorry. So if we want to translate this imperative not method that we had before into a pure functional construct, what we're doing here is sort of separating each side effect and having it sort of atomically wrapped into an I/O value. And so we are separating the pressing of the key, the weight of the given duration, and the release of the key. And we're composing those 3 things in a sequential fashion here. What's worth noting here as well is that we're not calling is that when you call IO.sleep, it doesn't block a thread. It's not going to monopolize resources for the duration that you say. It will merely schedule a sort of callback in a very transparent manner, so that you don't really have to worry about plugging callbacks together. And when you express this sequence of operation, you can have this sort of guarantee that release will be called as soon as the wait finishes, but it's not going to block a thread. It's going to be completely non-blocking and asynchronous. And that's really, really nice because you get to compose those things in a very simple manner, but you can write huge programs that are going to be compositions of very small ones. And it's going to be non-blocking. You're going to keep your resources, and you're going to get a lot of performance out of it without having to think too hard about it. Okay, so now we can sort of re-express our piano as we did before, using this pure version of the note. And the difference is now that we can express a song or a scale as a sequence of notes, as a list of notes, because now they're not being executed as soon as it's declared. They are merely being described or sort of enumerated within a list. And we can combine those things together using the sequence operator here. So it goes from a list of description of side effects to a description of a list of side effects. And then we're just calling void to say, well, we don't really care about what's contained by the IO anymore. But at this point, nothing has executed, and we're still in the declarative word or the side of thing. So we can keep going and compose things more and more. And we can, because we still have this list that hasn't performed any side effect, we can reverse it and do the same thing and compose the nodes together. And then we can repeat that. We can add a delay, and we can compose the two things and run them in parallel. And we still haven't run any side effects, so we can keep going and going as long as we want. And so this is where we have the second demo. So once again, I've translated the JVM code into Scala.js semantics so that I could sort of demo it within the context of this talk. Okay, there you go. And by the way, when I press stopped, I actually triggered the cancellation of the background computation that was happening using the IO construct, because yes, it cross-compiles to Scala.js, and you can use it in the JavaScript land. All right. So I'm going to talk a little bit about resource management. So one thing that I didn't sort of show in the previous slide was that in Java land or on the JVM, whenever you access some sort of resource that let you communicate with your system, you usually have to do a little bit of lifecycle management. So usually this involves using a try finally construct, and that construct is, you can find it in many languages, such as Java or Python or whatever. And that's how you would deal with it. You would sort of open the connection before the try block, then you would do something with it. And finally, whether the computation was successful or not, you close the connection. Pretty standard stuff. So the problems with this sort of out-of-the-box construct is that it's really tricky to get this to work within a concurrent context. So going back to the code, if we are performing something in the background, we would have to synchronously wait for the background computation to finish before we're able to close the connection. And that's problematic because you're going to have to block a thread for however long the computation is running. And it's not really sort of intuitive, the fact that you would have to do this. There's also the collateral problem of, well, opening and closing a connection to something that lives outside of your runtime is obviously a side effect. It leaves the context of your runtime, so it should be considered a side effect. And therefore, using the sort of try finally construct means that you're imperatively managing this connection, and therefore you're leaving the sort of side of the referential transparent word, and that imposes you to going back to having to reason about your program in terms of a sequence of potentially dangerous operations. So the CATS effect provides you with this resource construct that lets you manage connection life cycles or life cycles of any sort of resource that need to have its life cycle managed in a reasonably safe manner. And by reasonably safe, I mean, it actually has strong guarantees as to what it does. So the way that it works is that you express the acquisition of the resource and the release of the resource as pure functions using the same IO construct we saw earlier. And so it can be anything. It doesn't have to be necessarily a co-connection. You could create a resource that's going to sort of simulate a life cycle of an integer or a string or whatever value. And you have this acquisition function and this release function, and you combine them together using this resource.make construct. And so that binds together the 2 bits that form the life cycle of your resource. And that's, at this point, nothing has happened. We're still in a referentially, we're still dealing with a referentially transparent value. So we can assign it to value and compose it in a similar way that we did before with our music. And for instance, here we're sort of creating a resource that are creating 2 resources that are integers. We're composing those 2 integers to create a third resource by summing the 2 integers. And then we're transforming those 3 things into a list by just adding them to a list. And so we've sort of composed different life cycles together, and that gives us, when we're going to use it, it will give us a list of integers. And so we can define a function that is going to take that list of integers and do something with it. Whatever it is, we don't really have to worry too much. We just know that when we call this use method on the resource, so we're calling myResource.use and passing the function that we intend for, that we want we want the function to consume the resource. And that gives us, still an IO, so we still haven't really executed anything. We've still just described the fact we have some resource that is going to be used by a function, and it's still a description. And so when we run that program, what's going to happen is that all the resources will be acquired in the same order that we've described. Then the sort of the free or the consumption function will be run, and then the resources will be cleaned up in the reverse order that they came up in. All right, just gonna grab a little bit of water. Yep. Bear with me. Don't have much. Okay. Okay, so back to our music. So we saw earlier this talk that we were acquiring a reference to the MIDI system that lets us play music. Well, this time we're doing exactly the same thing that we did earlier with integers and creating an acquisition function that is going to wrap the opening method here into an IO by just composing a bunch of flat map and flat tabs. Those are sort of binds for Haskell, for instance. Then we are expressing the release of the device, the release of the connection, still in a referentially transparent manner by wrapping it in IO. And then we are expressing, or we are combining those 2 things into a resource using make. And then we're sort of transforming this resource into a higher level representation that gives us sort of easier construct. So that contains that pure piano here is what contains all our notes. And when we have this resource, we just use it to perform the song that we described earlier. Okay. So that's a little bit about resource management. It's interesting because of the fact that it fits in the test framework context, and I'm going to explain it a little bit after. Okay. So in addition to this IO construct and this resource construct, Cat's effect provides you with a bunch of very, very useful concurrency primitives that lets you manage state via an atomic reference sort of construct. It provides you with semaphores, and still all those things are purely transparent or referentially transparent. You use them to describe intent rather than executing it. So semaphores, for instance, are really useful if you want to implement some rate limiting logic to protect some service or something from a burst of requests or something like that. Promises, well, it's sort of a value that may be filled somewhere in the future. So it's quite useful to describe caching, for instance, combined with atomic references, etc. So it sort of provides you with those very useful concurrency primitives that are absolutely important for writing software in a maintainable manner. They're so concise that it's really a pleasure to work with those. And we sort of wanted to create a test framework that would consider those constructs as first-class citizen, and that would assume that all the tests that were written by the user would be sort of pure programs, non-side effecting, so that the test framework could take those pure functions and combine them together in a parallel fashion. So a little bit more about motivation. Scala as an ecosystem, as I said earlier, it's very what's the word I used? It doesn't try to make any decision or to push any sort of pattern down the throat of its users. It really tries to make it possible for everyone to express themselves in the way they want. And there's already a bunch of a number of different test frameworks that have existed in the Scala ecosystem for years. However, there wasn't one that was considering constructs such as IO, resources, etc., as first-class citizens, and using Cat's effect in combination with one of those already existing frameworks felt very lacking. We couldn't really compose things in parallel. We couldn't really benefit from this very principled way of managing resources. And we decided to try and implement our own test framework built on those constructs. And the main motivations were speed, because it's so easy to parallelize computations with those constructs that we really wanted to leverage this. We wanted to increase debuggability and maintainability. So I'm going to try a little bit, or they're going to try and express why our framework sort of provides those things. Okay, so this is typically what a very basic test suite would look like in Weaver. Very simple import. You just need to extend this interface here, this abstract class, and you have access to this test method that is going to sort of expect you to return some assertions or expectations, as we call them. And so you can return the IO directly without executing it yourself. It considers it as a first-class citizen, and therefore it knows that if you return an IO, it's going to be able to do something with it. So when you run from your build tool, when you run the test command from the build tool, for instance, this is the kind of reporting that you're going to get. Very simple stuff, very basic. However, something that we were trying to achieve was to get a very, very clear reporting without requiring from the user a lot of boilerplate. So for instance, in this example, we are checking that the list contains the value 5. And that's the report that we get. So Weaver tries and capture at compile time the expression that you're testing for. And if it fails at runtime, you will get this sort of very nice report where the expression is decomposed into all the values that led to its result. And you can very easily see what's the reason for it failing. And you also get the sort of line number at which the expectation was expressed or written. So no need for a complex DSL to perform expectation. It's just a macro mechanic to capture the expression you're testing. So one thing that really improves debuggability is that we aggregate the failure reports. So one thing that something that's been always very frustrating for me was when a continuous integration run would take maybe 10 minutes and there would be hundreds of tests running in it, and the CI run would fail, and then you would have to go to the logs and scroll up as much as, I don't know, like maybe a lot to find the one thing that failed. And sometimes, it would not really be easy to find it because you would lose syntax coloring, or not syntax coloring, but correlation. And finding it in the CI report would be hard. So in this example here, we're sort of expressing two different suites, each of them having a successful test and each of them having a failed expectation, or expectation that's bound to fail. And what we're achieving here is basically the aggregation of all the failures from all the test suites. And we are reporting all the failures at the very end so that you don't have to scroll up, and so that you instantly see what exactly failed. And if you're sort of using a powerful ID, you can even click in your terminal and it will take you to the line number where it failed. It's really nice. We also, because we were really wanting to buy into this sort of referential transparency property that makes it really nice to express programs, we've decided to make our expectations values and make them composable rather than having a failure being a thrown exception. So we are able to assign expectations to values, for instance, and we can compose them using a Boolean-like set of operations. Okay, so I talked about it quickly earlier, but we we have parallelism by default. So it's all obviously configurable, but we really wanted for this test format to be used for integration tests and end-to-end tests, or tests that talk to real systems that are deployed in the cloud, or that have like HTTP connections and so on. And usually using because of the added latency of talking to, or that's added by talking to things outside of your system, running tests sequentially is usually very slow when you have to deal with those things. And so we really wanted to have parallelism by default without it being like intrusive for the user. And in this example here, we are sort of writing a very simple expectation, and we're delaying the program that contains it by 1 second. And we're running this test 100 times over. So obviously, because we are delaying everything by 1 second, the total, like if we put the duration of each test together, it gives us 1 minute and 40 seconds. One pass meaning like the one suite, like everything passed in the suite. That's the report from the build tool. So we get, theoretically speaking, test run of 100 seconds from the point of view of the build tool that just sort of sum all the duration of all the tests together. However, if you ask your system, it's going to show you a 4 seconds run. So that's quite important when you want to keep your build times or your test runs slow. When we first converted one of our code bases to Weaver, we went from a 9 minutes and a half build time down to a 1 minute and a half. That's a quite steep improvement, and we were really happy. And yeah, then finally, there's resource management is achieved by this resource construct that I talked about earlier. So rather than providing some sort of before role and after role API, or sort of create and tear down, or whatever the semantics would usually be, we are expecting the user to override this shared resource method if they want to share some connection or some HTTP client between their tests. And so you have to override to sort of declare what type of resource your test suite is going to share between all the tests, and then override this shared resource method. And then from or in each test, you can pass a function rather than just a program or a sort of IO value. You can pass it with a function that's going to take the shared resource and return an IO of expectations or expectations. And it will, or the test suite, the test framework will handle the life cycle of the resources as you would expect. Namely, it will acquire the resources, then run all the tests, then release the resource. And it's really clean. And we've been using this, for instance, to share a single distributed queue consumer, and keeping by virtue of having a single consumer rather than one consumer per test, we were able to sort of really alleviate the amount of HTTP calls that are made by the test runtime, and therefore gain a lot of time doing that. Yeah, so that's pretty much it for me today. The sort of end statement that I'd like to give is that when you're writing applications that do a lot of complex things that are going to talk to databases and maybe distributed queues and have asynchronous components to them, giving the same care to your test as you give your user-facing application is really important, because the tests are what give you the confidence to make a deployment that the users are going to consume. And if you don't have good tests, if you don't have a high amount of trust in your test suites, then you're bound to have a harder time deploying as often as you would like to. So GitHub links, Cat's Effect is a library under the type level organization. Weaver Test is, well, under our own organization, Disney Streaming. Thanks for listening. We are, yeah, I was asked to say that we've got a few open positions in the London office and the Manchester office. And if you're interested or have questions about the position, you can email those two lovely people, Jenna and Sam. And yeah, we'll upload the slides for you guys to read later on if you want to find those emails. There you go. So not sure what's the best way now to.
Yeah. Let me chuck us back on here. Thank you very much. For questions, if people post any questions in the chat, I can pull them up. So if you want to ask stuff, we'll wait. There was one question which I'm going to bring up. I can click a button and everything, which is this one. Does Weave test work well with WireMock? Which I don't even know what WireMock is, so hopefully one does.
So WireMock is. Let me Google it. I always mix the two together, but I think WireMock blah blah blah. Oh yeah, it's an HTTP mocking framework. Yeah, okay. So what we tend to do is use a library called the HTTP4S, which sort of works, or it's sort of tightly coupled to the same library CatEffect and lets you directly mock your APIs in Scala, and that works better in general. But yeah, there's no reason why it wouldn't work. You would probably have to sort of lift the lifecycle management of your WireMock server into the resource sort of construct.
Yeah, that makes sense, definitely. Let me see if I can see if there are any questions back in the chat. I don't think there are. If anyone has any, we'll wait a moment longer. I'm trying to think if I have any.
That's fine. It's a Monday evening.
Yeah. There you go. How does Reaver test handle having different types of resources in the same test?
Yeah, good question. So because like the sort of decision that we've made is because resources are composable, it's up to the user to sort of compose them together in some sort of construct that would hold all the resources together. So it does mean that there's a little bit of boilerplate, but we thought that it would be a less overwhelming maintenance effort on our end, and we like not working. So, but yeah, resources are composable. You can do that in userland.
Mm-hmm. This is quite a big question, so
okay.
I'll throw it up, but we might not be able to get all the way through this. What happens on the JVM level when we use the parallel API in CatEffect?
Okay, so that's probably a question best answered by the CatEffect maintainers on their GitHub channel. They're really friendly people. But overall, what's going on is that you have this very efficient imperative runtime that takes your IO compositions and decomposes it and makes the decision to delegate the parallel or the asynchronous calls to a thread pool. So usually you can configure what thread pool the computations are going to occur on. I haven't sort of shown that because that would sort of take away from the time that I had to present the stuff that I wanted. But yeah, you can configure what thread pool your parallel computations are going to be run on. Sometimes it even happens that you don't need a multi-threaded environment. It can, like the thing that I did on JavaScript, it's a single-threaded environment. It worked perfectly well. So
yeah, I think that's one of the interesting things actually about CatEffect, which is because it's not just say threads underneath.
Yeah,
like
exactly.
Threads. The runtime does the sequencing, and that can work perfectly well on like the event loop style Node.js type worldview.
That's a very good point, actually. So the people from CatEffect or Zio or Monix essentially implemented green threads in userland. So obviously it would be better if the JVM supported green threads or light thread or whatever the name is directly from the runtime. But it's quite impressive that those people were able to do that in userland. Yeah, as you said, James, forking is not necessarily going to be meaning a sort of change of context or a delegation to the thread pool.
Yep. I don't think we have any more questions. I'll give it just a few more seconds, and then I think we'll be good.
Okay, cool.
Get your questions in now if you want to ask anything. One more moment. I think we're good. All right, cool. I don't think there's any more coming in.
No, there's one more. There's one more. It's incoming.
It's incoming. Okay.
Da, da, da.
Da, da, da. I'm waiting for it. Now that is a good question. What do you think of CatEffect 3?
Yeah, it's a bit scary. Like they're well, it's not out, or I only saw they talk about it from Daniel Spivak. I can't pronounce his name. I'm really sorry, Daniel. But yeah, it's an interesting restructure of the various abstractions that are provided by the library, and it's probably gonna make it easier for interoperability with the other libraries. That being said, like until it's actually out and we can play with it, I can't really formulate an opinion.
Yeah, absolutely. Cool. All right, so let me press more of the buttons. That's basically everything for tonight. I mentioned that we'd pull the Discord link back up, and we're going to. So if you want to join us on Discord, that's the link. The key thing to be aware of with the Discord is that when you join, it should, fingers very crossed, although we're still working on all this, it should drop you into a rules channel, and you need to press the little, there's like a blue thumbs up on the bottom of the rules. When you press that, it's supposed to change your permissions and put you into the channels and make it possible for you to see everything. We tested it once and it worked. I don't know if it works properly. If it doesn't, I'll be keeping my eye on the permissions and people joining and all that kind of stuff just in case. But please do come along and join us if you want to talk about it after this. Thank you very much again, Oliver. It's been wonderful talk.
It's been a pleasure.
Yeah,
thank you.
Definitely. All right, awesome. I will post the link in the chat now, just so that people have it. Fingers crossed that's going in the chat. Yep, I think that's basically everything. Thank you very much. Hopefully we'll be back next month. I think we are probably doing lightning talks next month at Lambda Lounge. So if anyone wants to do a short talk on just about anything, please do let us know via some means. I think our email address is somewhere on Twitter. And I imagine that Scala Manchester, hopefully you'll be back as well with more stuff to come, fingers crossed. Yeah. All right, cool. I think we'll call it. Thank you very much, everybody, and see you all on the Discord.
Cheers. Thank you. Have a great evening.